Hello and welcome dear learners to the NPTEL course on nutritional epidemiology, a way towards a healthy life. In the module 3 for dietary assessment, nutritional status and measurement error for chapter 34, we will be talking about the measurement error in dietary assessment. We have looked forward for the dietary assessment till now. Now we will be taking about the measurement error in the dietary assessment. What are the measurement errors in dietary assessment, and especially we will be talking about the indicators specifying it and a case discussion for that part. Okay, so what we'll do, we'll first try to understand what is measurement error in dietary assessment. So as we all know, accurate measurement is the foundation of nutritional epidemiology. Measurement error may cause a lot of issues with respect to the participant and even the values that will be taken ahead. So if we talk about the difference between the observed value and the true value of the variable. So there is a measurement error which is equal to observed value minus true value. So true value is something which we are more concentrating on, especially if you have to take the example, a participant's actual daily energy intake is something like 2200 calories. So the reported energy intake is 1800 calories and the measurement error is something 400 calories. So you can understand, like, reporting is something done little lesser over here and there is a difference of 400 calories. So why the nutritional measurement error matters actually? If you see this example where there is a difference of 400 calories, you may see there is a distorting, and you may find the importance actually that stating that there is a misclassification exposure level and even distorted prevalence estimation and reduced statistical power. So you will have a bias, you will have a high true association and create a false conclusion. So particularly it is a very problematic in terms of dietary assessment, and so where the measurement errors matters a lot. What are the sources of measurement errors in nutritional research? So you will find dietary assessment where you will get the recall bias, no, and even the proportion size estimation errors and social desirability bias. A lot of food consumption database limitations also creates to give the dietary assessment. Then comes the anthropometric assessment. You will have measurement in the standometers, you will have even the waist circumference, abdominal circumference. But incorrect weighting scales, improper positioning and observer variation may give lot of anthropometric assessment. And this is a very mass level that if you do this, this gives a more variations into the adjustment. Biochemical assessment, you have lot of ways of dealing with these errors. So sample contamination can be one, laboratory variability can be one, instrument calibration issues can be one, and so others also. So biochemical assessment also comes with lot of errors. In clinical assessment, what is the major error? The clinical assessment, the major error is very subject to interpretation. You may have someone actually who may come up with its own bias and is not able to communicate and overcome those bias. There is a very subjective interpretation for that part. Inconsistent examination procedures. So lot of a time actually there is examination which is needed, and the different variability actually which comes with an exam variation is more respective towards the time, towards the biases, towards the knowledge, towards the skills, towards the understanding of the human individual, might be a male or a female, with respect to age or caste and sim. So lot of inconsistent examination procedure which is respective to the subjectiveness of the assessor is more obvious. So what is we have understood over here? Understanding the error is essential for high quality nutrition studies and accurate interpretation. Now we'll try to understand the measurement error in dietary data. We have lot of errors actually which can be estimated, especially particularly when the data are prone to errors. Okay, because intake varies daily and depends on memory and reporting. We'll talk about random error, very unpredictable variable, and it comes from day-to-day variations, might be because of memory loss, might be because of the portion size estimation. Okay, and what is the effect? The effect is more variability, lower power and weaker association, and you will get harder to detect actually in the true effect. So this random error is something very unpredictable. Then comes systematic errors. It's like a bias, like misreporting, social disability, whether if you are reporting something as cookies or fats, or even for sometimes fatty food or junk food. So social disability is something which is a very systematic, what I can say, error which is being pointed. Recall bias, it is more like a strength which is to be given on the memory. So recall bias is also there. Proportion size is something like I feel, I understand in terms of the old or even the old measures or even household measures. So underreporting versus over-reporting. So you may say that there is over-reporting of particularly of green leafy vegetables, fruits and all that, and even a good quality or I can say healthy food. Then comes social disability bias. What is the social disability bias? Like actual, where you will have 3 soft drinks per day, and the report is like 1 soft drink per day. So it is like a social disability, which is something very difficult to get redundant of. Then comes differential versus non-differential measurement error, where you can say that the example is like everyone underestimates salt intake by 10%, and example is like obese participants underreport it more. So differential versus non-differential error. Then comes effect versus relative risk, where you can say that the bias towards the null, where the measurement errors weakens towards the true association. You will even have regression dilution bias, which leads to underestimation of true effects. Quantifying attenuation, where which is coming from observed effect, where you will find examples of misreporting across the group of population. So overweight and obese people underreport by BMI. By age, you may say parent reports on behalf of the children. Poor recall frequently with respect to the adolescents actually, which are underestimating or ignorance towards the study. Over adults, memory limits and portion estimation. So they may have a lot of time recovery issues with respect to recalling or even understanding the issues. By sex, actually, we may say by women with respect to men, where women underreport energy, men underreport alcohol and snacks. By education level, we talk about lower education, where it is being seen more reporting errors which are being seen with people who are educated, okay, and lesser actually for people who are educated for low education. So what are the methods to reduce our dietary measurement errors? So multiple recalls when we talk about weekly and weekend, and standardized where you talk about interviews, which is and a portion size bias. So biomarkers validation is also being very important with respect to automated systems, and you will find different methods to reduce the dietary measurement errors. Now we will talk about the quality control protocols. So in terms of anthropometric quality control, you may have training, which is very important over there, calibrated instruments and equipments actually to overcome this, where duplicate measures along with that which will reduce, and TEM precision actually, which is giving you more reasons actually to prove that anthropometry is also going with quality. Biochemical quality indicators, which are trying to talk about SOPs, which are very integral part actually to improve the quality over here for biochemical quality, and integral part actually and external quality indicators and proper storage, which will make more reasons that this is more applicable. Now we'll talk about the statistical approaches to correct the measurement error. So regression calibration, which is being given as one of the very important way to deal with this statistical problem. And then comes the measurement error models and validation studies actually in terms like comparing with the reference method and biomarker based calibration. So we can say that the measurement errors can be overcome if you are taking specification in terms of identification where the problem is. Now we will talk about measurement error in nutrition status indicator. We have lot of time nutrition status assessment which also suffers from measurement error, especially anthropometric measurements, even biochemical measurement and clinical examination. So measuring errors in anthropometry which is coming with uncalibrated, particularly weighing scale, damaged stendometer and faulty skin fold caliper. So you may come across with an estimation of a true versus exact actually. So errors in skin fold measurement is like triceps, biceps and subscapular and suprailiac. Particularly prone to error, heavily dependent on scales, and scales is very important in anthropometric measurement. Observation error where inter-observer variability, and sometimes it is like different according to the anatomical landmarks. And tape tension, very important issue, and inconsistent technique. Then comes intra-observer variability where morning and afternoon you may have a different set of a thing which comes like fatigue, inattention, technique drift actually. So you may have more. Then comes actually you may see that incorrect BMI classification and even overweight versus stunting and wasting. So inaccurate obesity prevalence estimate is also being seen over here. Measurement errors in biochemical indicators are more dealing from sample collection to transport to storage and laboratory analysis. Pre-analytical errors come more like wrong tube or incorrect blood or delayed transport and temperature fluctuation. So you can even understand like how sample collection is so important as well as even transportation. Then comes analytical error where reagent variability is very different versus to the example of true HB which is coming 12 grams. Exact measured is like 10.5. The consequences are more like misclassification of nutrient deficiency, incorrect prevalence and reduced study variability. Okay. Now we will talk about reducing measurement error. What are the key strategies? Repeated measurements means you have to do again and again, which will reduce the errors actually. Averaging the measurements, because you have seen multiple measurements, then you will try to get an average and that average will be pointed as a final assessment. Quality control protocols, if you are able to meet up actually this is more towards standardizing. It is most like standardizing training, standardized calibration tools and equipments, and test manuals, which is very important actually to improve, because in quality what we do, it is like even training also, emphasis on calibration and even developing on SOP. SOP is very important to highlight that how to reduce the measurement errors. The standard operating procedures are something which will give you more benefits towards reducing the measurement error, and this is how you can improve the nutrition research. Statistical approaches, advanced nutritional epidemiology studies are used with regression calibration which corrects the attenuation bias. Measurement errors models estimates the true intake from observed intake, and validation studies comparing the assessment tools with the reference method. Also biomarker based calibration, which is very important. So this way you can understand the measurement errors to be reduced. Now we will take a case study where the title is stating that underestimating sugar intake among adults and the impact of the measurement error. Here in this case study we will try to highlight how measurement error is impacting and how it is reflecting towards a very different observation. In the background of the study, a research team aimed to investigate the relationship between sugar sweetened beverages consumption and obesity. So among 500 adolescent aged groups among 13 to 18, the investigation was done and the dietary intake was assessed using a single 24-hour recall. So this was a study among 500 adolescents, and a 24-hour recall was done where their breakfast, lunch, dinner, snacks, evening snacks, beverages, and this was calculated what they have really consumed. The findings were that average reported was sugar intake was 35 grams per day, and the obesity prevalence among this all 500 adolescents was 22%. The analysis shows that only a weak association between sugar intake and obesity, so relative risk was 1.1. What are the potential measurement errors? The random variation within person variability. Okay, so adolescents do not consume the same food every day. They were eating different food on different day. Like Monday there was a different food, Tuesday it was different, and Saturday and Sunday it was more towards more beverages. A single 24-hour recall may not reflect the usual sugar intake, so it may vary on Saturdays and Sundays. Some participants may have consumed soft drink on weekends but not on the recall days. So these were the recall days. What is the systematic errors? Which is like more coming from overweight adolescent underreported consumption of soft drinks, chocolates, fast food, and the reasons were social disability. They were not afraid, but they were coming with preparation of social disability. They will give the results according to that. Participants forgot snacks eaten outside the school and home, so recall was also the thing. And portion size was something actually which was giving lot of underestimation. Okay, so I should report this, I should not report this. So what were the consequences? The true sugar intake was underestimated. Participants were misclassified into lower intake categories, and the association between the sugar intake and obesity appeared weaker than the actual, because the actual was something different. So the sugar intake was something which was very high, but the report was not coming in that. So obesity risk was something which is coming as consequences. What is the improvement strategy that we have done? The researcher conducted a validation study, which is a sub-study where day 1, day 2 and day 3 where 3 different reports were taken for 24-hour recall, and a food frequency questionnaire was also taken. After correcting for the measurement, it was observed that average sugar intake increased to 52 grams per day. And what was the previous? 35 gram. So there is a great difference. So relative risk increased from 1.1 to 1.8. So you can find what is the great difference over there. So what is the conclusion of this case study? This case demonstrates that both random error, day-to-day dietary variation, and systematic error, underreporting due to social disability, can substantially underestimate the dietary intake and weaken the observed diet disease relationship. So here also there were error, and here also there was error. So what we need to do? Repeated dietary assessment that is being done over here, and validation methods. Along with this, there was other method was also done, which are very essential to improve the accuracy and can obtain the reliable estimate of the risk, because the diet and the disease risk is something which is very important, which was the purpose and outcome which was expected, because the objectives was more towards understanding the obesity among the adolescents. So with this, we have come an end to this chapter, where we have discussed about the measurement error, which is being seen as a major challenge in dietary assessment, and it occurs when reported dietary intake differs from true intake. So true intake is very important compared to the reported intake. So it can be random because due to day-to-day variation in food consumption and recall inaccuracies, because you can eat on different days different things. Or systematic, that is due to consistent underreporting or over-reporting of food because of social disability. Common sources include memory limitations to recollect and all that, portion size estimation with respect to the proportion and the size and even measurement, and even social disability as I stated. Measurement error can weaken observed diet disease association, and it also can lead to attenuation of relative risk and bias towards the null. In terms of misreporting is often more common among individuals with higher BMI and certain age groups, especially older, and varying educational levels, especially in people actually who have low education. Strategies such as repeated dietary assessment, standardized protocol, and use of portion size aids and biomarker validation, and also adding quality protocols can help improve the accuracy and also the reliability of dietary data, which is one very important to help the nutrition research. So these are few references that can be used, and this can help you to understand to reduce the measurement errors. Thank you.